everybody, this is the last part of box plots, also known as box and whiskers. This is talking about comparing box plots. And this is a tricky thing that students think, oh, it's easy, but it can become a little bit of a trick. Let me show you what I mean. So, boom! I look and I see I'm comparing two box plots. And I ask the question, hey, who did better? And people go, well, let's look at this. Well, this top one, they started at 5 and they went all the way up to, looks like 17, and they had an outlier at 26. But this one, they started at 3 and they got to 26 and they had an outlier at 34. So it's obvious, right, that this one did better, right? Because it has more data, where this has 75% of this data is less than 50% of this data. So we're like, oh, it's obviously better. But the thing is that we didn't ask the question, what are we talking about? And this is where things become important, because when I look at this and say, wait a second, the title of this comparing data is absences in a school year. You're like, wait a second, is absences a good thing? No, absences is a bad thing. So wait a second, then if absences is a bad thing, I actually want the class that actually had less absences. And if you look at the top one now, you say, oh, I see. The top one actually did better. And this is what we're talking about, is that you have to title your data so that you understand what you're looking at. You also need to know what you're talking about. Oh, this is the first period, this is the second period. And because now we know this is about absences, well, look at this. Almost 100% of my students had less absences than about 25% of second period. So you can see there's more kids with less absences. So this one did better. So again, talking about box plots or comparing them, you need to know what you're talking about. So Mr. Nelson, come on up here. Who did better, Mr. Nelson? Who did better?
Well, it looks like it's A.
You're thinking A. A obviously did better. Well, what if I said, Mr. Nelson, we're talking about golf?
Well, points are bad in golf. So you don't want points. Now B's done better, because we have most of the data, almost 100% of the data in B is below 50% in A. So it looks like B scored less points in golf.
And you want less points in golf, by the way. That's the deal. Less hits of the ball to get it into the hole.
So whoever A is did worse in golf. But if it were football, now we want more points, and so now A is done better. So context is key here. Context is king. We need to know, and this is why you should label all your box plots of whatever the data is, right? And so which team did better now in football? Well, that'd be team A, right? Right? So it doesn't matter, but we do need context. We're talking about points here. Even if I remove this, right? Well, football, well, who did better? Well, what are we talking about? We're talking about a score? Are we talking about fouls? I don't know. So we do need to know context even within the game too. So points scored per game is really good. So which team did better? Golf? Well,
golf,
team B. Football? Team A.
So when you're comparing two pieces of data, know what you're talking about, and then look at your data. Let's try one more.
All right.
All right, look at this data. Oh, this is a quick jump back from time. Okay, minimum, what's the minimum?
Oh, we can do this. This one's tricky because we don't have a whisker here. So the minimum, well, that's the farthest left point, that's 9. Right? First quartile? Well, the first quartile is where that box starts. So it's also...
But Mr. Nelson, how could that happen? How can the minimum in the first quartile be 9?
So remember that in any box plot, each section has 25% of our data, right? This just tells me that 25% of my data is a 9.
So a bunch of people scored the same score, hence they're all in there. So
all of these are 9s.
My ideal would be, this is a 0 on the test, this is a 4 on the test, right? And this is a 2, right? We want people to get 4s. Well, my ideal would be, my box plot would look like this. What would this mean, Mr. Nelson?
That would mean that 100% of your students got a 4.
Whoa! Oh yeah, but I gotta remember about Aspen. So, would I do that? Or would I just call
that an outlier?
Not an outlier.
That would be an outlier.
That would be an outlier. Aspen, fix it. Just kidding. All right, go on, sorry.
All right, so our median, the median is always in the middle of the box plot, right? So 11. Our third quartile is the end of the box at 13. Our maximums all the way, not right here, because the outlier is included in our maximum. So our maximum looks like it's 27.
It is an outlier, but it's still our maximum.
Our interquartile range is the width of the box, but I just usually take Q3 minus Q1 and 13 minus 9. What is that?
They're gonna be polar.
So our interquartile range is 4, and do we have any outliers? Yes, we just talked about that, and that outlier is 27.
And the way we'd find that is 1.5 times 4, which is the interquartile range.
Yeah.
And that would let us know whether or not.
What
What percentage of my data is each quartile? Well, I think Mr. Nelson just answered that
I
one.
did. I should have just wrote it up here. What percentage of the data falls between 9 and 13? Now this one's tricky because 9 and 13,
It looks like 2.
technically, it looks like there's 2, so 50%. But remember, 9 is the minimum, and then 13 is the Q3, right? So we took how much of my data is between 9 and 13. But remember that a box plot with whiskers on both sides, this is the minimum. This is Q3. There's actually 1, 2, 3.
75%.
Yeah, so that's actually 75%. So, all right, what percentage of the data is below 11?
Oh, tricky again.
11 right here. So how many sections are technically below that? Well, we have this one. And we also, going to the minimum, we have to include the 25% of the 9s there, right? So that's
It
actually,
doesn't look like anything. It's still 25%
Yeah.
of my data.
again, 11 is our median. 11 is exactly, if this is all of my data right here, the median cuts it right in half. And if that's the median at 11, well then that's 50% of my data below it and above it, right? And so because 11 is my median, that's going to be 50% below.
That's pretty cool, Mr. Nelson. That's pretty cool.
Yeah. Okay.
One more like it. What's my minimum? Well, again, like Mr. Nelson said, my minimum is not going to be 16. It's actually quite. You can do it.
I can write.
Outlier is going to be, my minimum is going to be an outlier, which is going to be 4.
Right there.
That's just somebody outside of the data. Okay, and my first quartile, well, that's where to be where I got my box at, so it's going to be 21. My median is my Q2, or that's going to be 23, and my quartile 3 is going to be 25. Well, I could say I shifted that. And then my maximum, well, that's my biggest data point, that's going to be 30. My interquartile range is my Q3 minus my Q1, so I have 25 minus 21, which is going to give me a 4, and then to find out whether or not I have outliers, I multiply 4 times 1.5. And in this case, 1.5 times, now you can already tell that that piece is going to be way out there. So my outlier is 4. Still part of my data. I still got to tell this kid got a low score on the test, but I still got to put him as part of my data because he's part of my class, even though he's the only kid who got that score. So I'm saying he's part of my class, but he doesn't represent really my class. All right, I think that's it. Get to work, take the quiz, do great things in life. Go team, go.